Welcome back to AI with Justin. In the first two parts of this series, we overviewed some core concepts of modern AI. And in this video, the last of the series, we'll observe those concepts in the context of Chat-GPT. Firstly, Chat-GPT uses a special expansion on neural networks named the transformer. The transformer combines the type of neural network covered in the previous videos with special mechanisms that allow the network to associate inputs better. This doesn't change any of the concepts taught in this video, but it's important to know that the transformer exists and that it's very effective. Secondly, Chat-GPT has not one, but three sequential training stages. First, pre-training. Second, supervised fine-tuning. And lastly, reinforcement learning from human feedback. Each of these stages has a different objective function and serves a different purpose. Let's walk through each one of them one by one. During the pre-training stage, the objective function is to predict what the next word will be based on preceding words. Essentially, the model reads through a bunch of text, making predictions as it goes, and observing how many predictions it gets right. And when I say a bunch of text, I mean a lot, like many terabytes. Note that predicting the next word is sometimes just statistic-like inference. We know that some words are naturally more likely to follow others, but other times words can only be inferred only depending on very complex context, and this context may literally be some type of understanding of the world. Language itself is developed by humans to represent the world, which means that to most accurately predict the next word, the model must truly learn some representation of the world itself. The bulk of knowledge that Chat-GPT acquires is during this pre-training stage. Given the billions of dials which must be adjusted, this training goes on in large data centers for months and costs millions of dollars. However, while the model acquires a lot of knowledge during this stage, it isn't quite set up to use its knowledge to best interact with humans. And this makes sense, considering that the pre-training data includes all sorts of text, not just human dialogue, and even the human dialogue it's trained on is not all service-oriented, like we want our chatbot assistant to be. So the next two training stages serve to adjust Chat-GPT's dials in a way that it doesn't lose too much of what it learned during the pre-training stage, while at the same time learning to structure its output ideally for human consumption. This is usually referred to as aligning the model. The first alignment stage used to create Chat-GPT is supervised fine-tuning. Supervised learning is when each entry in the training dataset also has a corresponding target that the model should aim to produce. For example, an entry in the supervised training dataset might include a passage, then ask a question about that passage, and the target would be a response to the question that both includes the answer and is formatted in an ideal structure for human consumption. So to put two and two together, this means that the objective function for this stage is to produce an answer as close to the target answer as possible. The second alignment stage is reinforcement learning from human feedback. This stage has two main parts. In the first part, a secondary model is trained using supervised learning on a dataset of human preferences. An example of this is a passage, two responses, and a human annotated target of which response was better. The model's objective is to correctly predict the human annotated target. By doing this, it learns some understanding of human preferences. In the second part, the primary model generates text, sends it to the secondary model, and the secondary model gives it a score based on how well it fits with its understanding of human preferences. This repeats, and the primary model attempts to increase the scores it gets from the secondary model. So the objective function for the primary model is to increase the score it receives from the secondary model. At the end of this stage, we have Chat-GPT.